We're going to now take a look at how the P-Link devices are programmed, starting with the Class A card. When we're on the Class A card, we're talking about the CA6075 or the CA6500. In this case, I'm working on a PFC-6000 program, so this is the CA6500 card. If the card is going to be installed, I can add this to the program by clicking on Add Device. I can only have one, so it won't let me add any more, and from here I can decide what is going to be Class A. The CA6075 and the CA6500 provide the return terminals for the P-Link, the SLC, and the notification appliance circuits. You can individually configure which of those are going to be Class A. If your entire system is going to be Class A, you'll need to switch these both to Class A. If you just want your SLC to be Class A, the P-Link can still be Class B. What you don't see here are the notification appliance circuits. Those circuits need to be wired either Class A or Class B. Each of them individually can be wired one way or the other. So for example, on the 6800 you could have NAC 1 be Class A and NAC 2 be Class B, simply how it's wired. If you want to delete the device, simply click on the device and click Delete Device. Moving to the LCD annunciator. This refers to the RA6075 and the RA6500. You can have up to 31 of these installed on the system. I can just click Add Device and it adds LCD annunciators. If you had run a Learn and had these installed in the field, they would already be here in your program. You'll notice it does not distinguish between the small annunciator and the large annunciator. The panels don't know the difference, so they are interchangeable. You can edit where it says Name, giving this a name of some sort. This name will not show up on the LCD screen of that remote annunciator, but it will help you in troubleshooting if there is ever an issue with the remote annunciator. The address that you see on the right-hand column has to do with the dip switch setting on the back of the annunciator. This needs to be some number between 1 and 31. You can go out of order. I could start with address 10 here. This one could be 12. It doesn't matter. Just some number between 1 and 31. They need to then match the actual devices that are installed on the system in the field. They need to match their dip switch settings. So for example, if I download this into my Fire panel, I should have a remote annunciator that has a dip switch setting of 10. I should have a remote annunciator with a dip switch setting of 12. If I want to delete these, I simply highlight them and click the Delete button. Moving to the SLC loop. This is adding SLCE expansion cards. The PFC-6000 you can install up to 7, and the PFC-6200 you can install 1. I simply click Add Device, and it will add SLCE cards. Again, if you had already installed these and run the Learn and then uploaded the program, you would already see these in your program. So once I have these in my list, I can go ahead and name these. I would recommend naming them. It's going to make it easier to know which card you're working with in the points list. We're not dealing with the points on these cards at this point. We're just adding the actual P-Link device, the card itself. So for example, I'm just naming them the floor that potentially they're going to be installed on. Each SLCE 127 needs an address between 1 and 31. In the address column, you can designate that address. It starts with number 1, but you can change that to any number between 1 and 31. It just needs to match whatever is actually installed in the field. And this is the P-Link address, so this is the 5-position dip switch address of the device. And again, you can delete these individually by highlighting them and clicking on Delete Device. You can also designate whether this SLC circuit is going to be Class A by hitting the down arrow here and switching it to Class A. The return terminals are provided on the SLCE 127 card to make this circuit a Class A circuit. By default they are Class B, but you can switch them to Class A in this column. Moving next to the power supply. The power supply deals with the PSN-1000. These are the smart power supplies that are connected via the P-Link to the fire alarm control panel. You can have up to 31 of these on any of our systems. Click on Add Device and this will simply add PSN-1000s. Again, I would suggest naming these so that you can easily see which device you're working with when you get to the points list. And again, we're not dealing with the points that are actually on this device. We're actually just adding the device, the P-Link device itself. When we get to points, we'll be able to configure all of the points on the PSN-1000. The address column allows you to set the address. Again, these devices have a 5-position dip switch on them. They need some address between 1 and 31. Again, you can change the address any number between 1 and 31. You can also designate the class of wiring that is coming off of the PSN-1000. The isolated P-link repeater, that can be a Class A circuit by switching this to Class A. NAC 1 and NAC 2 can be a Class A circuit by switching this to Class A. NAC 3 and 4 can be a Class A circuit, and NAC 5 and 6 can be a Class A circuit. Each of those is individually configured depending on what you need for your project. And again, you can delete these by highlighting them and selecting Delete Device. Moving to the DRV50, this is the LED driver. You can have up to 31 of these on a PFC-6000, and you can have up to 10 of them on the other panels. So I'm just going to add a couple here. You can go ahead and name this. Maybe this is for your annunciator panel. And again, this needs some address between 1 and 31, and you can adjust those here or leave them as the default numbers. We're not doing anything with the 50 points that we have associated with this card. We will adjust that in the Points tab. Again, if you want to delete these, you highlight it and select Delete Device. You can highlight multiple by holding the Shift key down and selecting multiple devices. So if I click here and then hold the Shift key down and click here, I can delete multiple at one time. Moving to the LED 16, this is the LED annunciator. This is a 16-zone LED annunciator. I can have up to 31 of these on a PFC-6000, and I can have up to 10 of them on all of the other panels. Again, I'm just adding the actual annunciator. I'm not doing anything to designate when the LEDs turn on. I'm going to do that in the Points tab. Again, I would name this. This name is just going to help you in troubleshooting, but it will at least distinguish the annunciators for you. In the address column, these devices need some address between 1 and 31. Again, you can change them from what is assigned by the software, or you can leave them as the default. Moving to the RLY5, this is the 5 programmable relays. Again, all we're doing here is adding the actual card to the system. We will program the relays when we get to the Points tab. I can have up to 31 of these on any of the panels. When I click Add Device, it will add up the cards. It will give them the default address. It will count up consecutively. Again, I can change that address. That is the address of the dip switch that is on the card. Again, you can name these. It'll just be stored in the card, but it can help with troubleshooting. Moving to the FCB-1000. The FCB-1000 is the fire communication bridge. This is the remote Ethernet connection. You can have one of these connected to any of the systems. I'm going to go ahead and add a device. You can go ahead and name this. The address is 1. It will actually take any number between 1 and 31, but I would just leave this to address 1. Make sure the dip switch on the FCB-1000 is set to address 1. And if you expand this, you can adjust the network settings of the FCB-1000. By default, it's DHCP, which is Dynamic Host Configuration Protocol, which means that this Ethernet connection is going to try and automatically obtain an IP address from the network that it's connected to. If that network has a host computer or a DHCP server, it will probably successfully get an IP address. That does not necessarily mean that it'll have access to the internet. You may need to talk to the network administrator to make sure that that IP address has access to the building network as well as the internet. If the network administrator would like to assign a static IP to this connection for IP communication to Central Station, you can go ahead and select Static IP. You'll need to get from them an IP address, a subnet mask, a default gateway, and a DNS server. There are spots here for 2 DNS servers. You don't actually need 2. If they give you an alternate, go ahead and fill that in. If they only give you 1, just put that in the preferred location. This is information that you will receive from a network administrator. Again, the default is use DHCP. Now looking at the SPG-1000, this is the Serial Parallel Printer Interface card. You can install up to 31 of these on any of the PFC series panels. Click on Add Device to add a card to the system, and here again we can adjust the name to help with troubleshooting in the field. You can also change the address. These devices will take any address between 1 and 31. Make sure that the dip switch on the SPG-1000 that is in the field matches the address as programmed here. If you are connecting to a parallel printer via DB25 on the SPG-1000, check this box to log events to that printer. If you check this box, the SPG-1000 will continuously monitor the connected printer for an out-of-paper condition. When that condition happens, a trouble event is generated and enunciated at the panel. If you select this box, Supervised Offline, the SPG-1000 will continuously monitor the connected printer for an offline condition. When this condition occurs, again, a trouble event is generated and enunciated at the panel. If you select Supervised Offline, then this time is the time the condition needs to be present before the trouble event is generated at the fire alarm control panel. The default time is 60, and that is in seconds. If you are connected to a serial printer via the DB9 connector, select this box to log events to that printer. If Supervised Port is selected, the SPG-1000 continuously monitors the connected printer for the presence of the serial printer. If not connected, a trouble event is enunciated at the fire alarm control panel. If you do have Supervised Ports selected, you can set up the offline time. This is the time that the condition needs to be present before that trouble is generated. The default here is 0 seconds. You can adjust the baud rate. This is the rate used to transmit data to the connected printer. The default is 9600 baud. You can hit the down arrow to see your options. It goes from 1200 to 38,400 baud. Under Flow Control, you can select None, Hardware, or Software. This specifies the flow control method when sending data to the printer. Please refer to the specifications of the connected printer for the proper setting. The default is None. Data bits. This option specifies the number of data bits used when sending data to the printer. The default is 8. You can choose between 7 or 8. Please refer to the specifications of the connected printer for the proper setting. Under Parity, you can select None, Odd, or Even. This option specifies the parity used when sending data to the printer. Again, refer to the specifications of the connected printer for the proper setting. Under Stop Bits, you can select between 1 or 2. This option specifies the number of stop bits used when sending data to the printer. Again, refer to the specifications of the connected printer for the proper settings. Again, you can have a total of 31 SPG-1000s connected to the system. To add another one, simply click Add Device and go through the settings. Moving now to the FIB-1000. This is the Fiber Interface Bridge. To add an FIB-1000, click Add Device. The FIB-1000s need to be installed in pairs, so you will need to click Add Device one more time to get 2. They do need to be addressed consecutively, so the default address here is 1 and 2. We're going to leave it that way. If your fiber connection is going to be Class A, you would go ahead and select Class A here. You can, of course, name these devices for help with troubleshooting under the Name column. If you are going to install another pair of FIB-1000s, simply click Add Device and you will have 2 more FIB-1000s installed. You can have a total of 30 FIB-1000s or 15 pairs installed on every system in the PFC-6000 series. For more information on any of the P-Link devices, installation, wiring, and programming, please refer to the installation manual and the other recorded modules. The next video in this series is Points. For more information on programming, please refer to the installation manual and find other resources on our website, www.pottersignal.com.